Hi, my name is Jamie Smith. I'm a product marketing manager here at Elastic. Today we're going through Elastic for Operational Analytics. I am joined by my colleague, Dale McDermott. He's a product marketing engineer. We're going to run through a few slides, talk a little bit about the problem space that we're looking to solve, and Dale's going to give us a nice demo. As far as some housekeeping and logistics, there will be slides and a recording available following the webinar, so you feel free to look at those later. If you want to get involved in the conversation, you can join us via IRC. We're at Freenode. You can join us with the hashtag Elastic-webinar. And of course, if you're watching this recorded, you can't do that, but you can make sure you click high resolution in your YouTube video player. First thing we want to try to do is set the stage and get on the same page with the problem that we're trying to solve here. First, we're going to talk about the why. If you look at your environment and your infrastructure, you have lots of these: servers, routers, gateways, all kinds of hardware. You also have this: software, application, and services. And more, we're starting to get things like this: little sensors, all these kinds of smart stuff, things that are capturing and measuring all kinds of metrics and information in real time and needing to store them somewhere. All of these things, the hardware, the software, and these smart things, are generating lots of data. They're generating data that looks like this: structured or semi-structured logs and events, or things like this: numbers and metrics, the kind of data that tools periodically collect, things like the health or the status of services or applications or hardware. Our task is to take all of these logs and metrics from all of these things and do something meaningful with it, something that lets you run your business better and in turn serve your customers better. The end result ends up looking something like this: rich dashboards and visualizations that help you keep track of things in real time, as well as analyze and compare to historical trends. More and more, we're also getting into smarter and more advanced analytics, things that go beyond dashboards and charts with machine learning and predictive analysis. Things like this: proactive alerts that keep you informed immediately when something needs attention, rather than relying on catching things via human inspection and having to wonder if Bob in the NOC is going to realize we're a couple of percentage ticks off on our CPU utilization. That's the thing. The audience in this webinar are tasked with this: bridging the gaps between that raw data we saw from all the organizations and turning it into knowledge and insight that lets you run your business better. When we ask groups like this, organizational goals or objectives that drive these initiatives is usually some combination of these things that we see on the screen here. All of these kind of things feed into higher level mission statements that are tied to the business. These are things that often appear in a company's annual report. Stuff like improve user experience or reduce user attrition, maybe increase employee productivity and reduce time to resolution. One of our current customers stated that in the 17 years that they've been working, Elastic is the most effective tool that they have in their tool belt to help turn around issues. So how do we get there? What kind of things do you need from your tools to go from data to these insights so you can actually achieve these organizational goals? You need all of this stuff. Any project focused on data to information is going to have these requirements. You have to make sure you have tools that can connect to common data sources and deal with or transform and enrich structured and unstructured data, and that it allows you to store and analyze vast amounts of data. We need support for basic and advanced analytics, including more and more machine learning features. We definitely need a rich query language, something that supports the ability to search and drill down. And we need a dashboard that's integrated with that to have visualization features to go with it so you can actually slice and dice your data. We need to make sure it provides real-time and streaming support, and it has to have an alerting framework so you can connect it into your current notification systems of choice. And possibly most importantly, it has to provide rich APIs so we can integrate with other systems. Elastic has all of this and checks all of these boxes. As Dale's going to show a little bit later in a demo, but we think those are table stakes. Instead of going through a laundry list of features, we want to take a few minutes and talk about why Elastic is uniquely positioned to help solve this problem better than the other solutions in this space. We're going to talk about what makes Elastic unique. Why are organizations big and small across all geographies and across all verticals betting on Elastic as their platform for operational analytics? Based on conversations with people in the companies you see here and people like yourselves on the webinar, we think it boils down to three different reasons. First, scalability is more than a checkbox. It's not just a buzzword that goes on the website. It is core to what we do, and it's who we are. It's deep in our DNA, and it's ingrained in our development philosophy. If a feature doesn't scale, it doesn't go GA. We have examples of PRs for features that people have been asking for that behaved great and worked when they were in small installations, but didn't necessarily scale and behave in the larger installations. These things didn't make the cut. For you and us, scalability doesn't just stop at technical feasibility. Performance, cost, and ease of use are just as important. Elasticsearch's wide adoption in the enterprise was largely driven by how simple it was to scale. Something that starts as a weekend project on one machine could be taken into production, running on hundreds of nodes with very little effort. You could start on a laptop, move to a cluster with thousands of nodes in a jiffy. Third thing that we think is important in this area is how much is scale going to cost you. We have multiple customers that moved over to ElasticStack, not just because of the technical benefits, but also because they simply couldn't absorb or justify the cost of the alternatives. Here's an example. Sprint went through a POC for an end-to-end view of phone sales and provisioning, and they did this with Splunk. In the end, it was going to be $1 million a year for the licensing, and it would have required all the groups involved to give something up, some of their existing tools that they were using. That solution was seen by those groups as a non-starter because nobody wanted to give up any of their current tools. Now, Sprint is happy to call Elastic part of their tool belt. A big drawback to other tools in this space is that query performance takes a hit when running things at scale. That means you might have to wait 10 minutes or a few hours for a response. When things like that happen, you're naturally going to ask fewer questions. That's not good for your business. That's not good for your customers. With Elastic, we don't let scale hamper your relationship with your data or your ability to ask as many questions and get answers quickly. Second observation we've made with customers going with Elastic is how easy it is to go from one node to 1,000 nodes, which means that you're building for a future scale from day one, and you don't have to re-architect your system in 6 to 12 months when it's successful and you're operating at 10 times or 100 times the scale. The final aspect of this area is cost. The cost to scale ramp up with Elastic is much more favorable than other tools in this market. We strongly believe that the licensing cost of your data platform should not be the primary driver of your data retention policy. The second area that makes Elastic unique is this. If you look at the infrastructure monitoring space right now, there are a lot of these little micro segments. There's niche tools in each category that do a specific thing. Right from the beginning, we've resisted being defined by a Gartner segment. We are not a log management tool. We're not just an APM tool or a time series database or even a SIM. We've pushed back on these labels, and instead, we focus on building a platform that allows you to collect all kinds of data and make sense of it at scale. Text and numeric can coexist. Metrics and logs can be analyzed together. You don't have to choose between real-time and historical, and you don't have to take your data out somewhere else for anomaly detection. This commingling of things that have historically needed niche products is another reason that organizations have been gravitating towards the Elastic Stack. With that, your problem spans silos. So should your solution. The average organization has 10 or more monitoring tools. Using Elastic, you can rise above these silos and get great visibility into your operations. So when things break down and you hop up on a conference bridge or in a war room, you're not pointing fingers and trying to troubleshoot from a bunch of different applications and hardware. Instead, you're looking at these things, different applications and hardware in a single place, and let you communicate faster across your teams and resolve problems quicker. Another customer had been using tools cobbled together for monitoring, but now ingests over 4 billion records a day from 69 different applications. This kind of unification, enabled them to catch and stop a multi-vector fraud attempt, which happened on Black Friday. The third area that makes us unique is open source. The benefits of developing the open source community are well documented, and we all benefit from that. It lets us move quickly, tap into the power of the community, and benefit from quicker user feedback loops. It even gives us insight into use cases that we hadn't even contemplated. We can pass many of these benefits on to you implicitly, but open source software is beneficial to you as well, and the benefits go beyond just cost. Developers, they're the new kingmakers. Good ideas come from everywhere in the organizations. Organizations big and small are doing amazing things with the Elastic Stack and pushing Elastic into areas that we didn't imagine, continually pushing us to innovate. All because a developer had a problem and just a weekend to solve it. Open source software lets you tap into these force multipliers. You don't have to limit yourself to ideas from your internal organization, but you can leverage the community as a whole. Now we're going to take a brief dive just to talk about the products so we have an understanding for the framework for Dale's demo. At the heart of the Elastic Stack is Elasticsearch. It's a distributed RESTful search engine, search and analytics engine, which lets you store and unify your metrics, logs, and data and correlate across them. Logstash and Beats are our data processing pipeline and lightweight data shippers, and Kibana is the dashboard providing rich and robust data visualizations. We also have XPack, which extends and hardens the Elastic Stack, providing security such as authentication and authorization, and audit logging and encryption, lets you safeguard data down to the field level, the kind of things that help keep getting on the front page for the wrong reasons. We also have alerting and monitoring and a rich graph API, as well as machine learning. In Dale's demo, he's going to be talking quite a bit about the machine learning, monitoring, and alerting. We have the Elastic Cloud, which is our hosted service, software as a service, which comes with basic support, as well as Elastic Cloud Enterprise, which lets you host your own Elastic Cloud on your own environment and monitor and manage your own users. Next, we're going to take it to a demo from Dale.
Thanks, Jamie. So let's take what Jamie's been discussing and get a little bit more hands-on with the demo. So far, we've talked about how the Elastic Stack can be used to address the operational analytics use case. Here, we're going to demonstrate using the search and drill down capabilities of Kibana to identify potential site issues and then make a root cause analysis. So before looking at a dashboard, let's just quickly familiarize ourselves with the data set that we're going to use for the demo. And in this case, we're going to use website Apache logs from a popular website, which you might be able to determine as we progress through the demo. To do this, we're just going to use Kibana's Discover view. So this data set runs from, as you can tell from the top right, the 1st of January to the 24th of March of this year. And we're going to assume for the purpose of this demo that the date today is 8 o'clock in the evening on the 24th of March. We've ingested this data through Logstash and we've enriched the IPs with geo-information. So I'm just going to do a quick search here for requests that have come to our website originating from Windows machines. Now, every line in the request logs, in these Apache logs, is a single request or a single page access to the website. So looking at the JSON view and the raw view of the data, we can see immediately that our IPs have been geo-resolved and enriched with the country, the location, our latitude and longitude. And additionally, our user agent information is being pulled out using the user agent filtering Logstash to the operating system. And there's a couple of key fields that we'll refer to throughout this demo. The first is this site area _1, which represents the first portion of the URL. And the second is called site area 2, which represents the first two components of the URL. Okay, so before we explore the issue, let's just go and look at the visualizations themselves. And I'm going to load a dashboard which provides us an overview of our web logs. Going through the visualizations here, we've got some key metrics on users at the top, a gauge just to show the expected response time. As you can see, it's currently green and falls within expected bounds. We're showing HTTP response codes over time, split by the actual response code itself. Beneath that, we show bytes and response times over time. As you can see, we have a pretty international distribution with respect to users accessing our site. And then referring back to this site area _1 field, this shows the most common accessed areas of our website, which is restricted to assets, downloads, blog, and products. Beneath this, we show accesses by country. And as you can see, we have very different access patterns depending on the actual country itself. This is probably something that would be interesting to maybe our marketing team to see whether these spikes correlate with particular campaigns. Finally, we show the country and the operating system, and by the country. So, for example, XP still got some usage in Russia. And then finally, we show the prominent cities of the world, so dominated by the global megacities. For this particular issue, we're going to actually try and look into this spike in 404s that have occurred in the last 3 weeks of March. So historically, these 404s were fairly consistent. Maybe these are just simply bots accessing invalid page links or people trying malicious activity on our site. But in the last 3 weeks, we've had a sudden spike in activity. So let's just quickly see if we can see what the cause of this was. I'm going to search for 404 to restrict the documents that are responsible for these visualizations to those that contain this value. Now, here, immediately, the visualizations are all immediately restricted, but you'll notice that I've still got some other status codes, and that's because this particular query is actually just looking for 404 anywhere in the document. So 404 may have occurred in the user agent, for example. So I'm going to restrict this a little bit further and limit it to status code 404, so the specific field that I've used to build this visualization. Restricting to that, and I would expect the other status codes to disappear, which they have. Okay, let's now restrict to the period that I'm interested in, which was the end of March, and apply a time filter to the dashboard. Now, when I first investigated this issue, my immediate suspicion was that maybe these 404s were maybe they were due to some sort of bot activity, or maybe they were located to a single geographical location. That's been disproved quite quickly. We can immediately see that our distribution really hasn't changed. Our cities have pretty much remained consistent through the word cloud here, and we don't really have much to change in the distribution by country either. But what should jump out immediately is that now the areas of our site the accesses are dominated by the /assets portion of our site. Now in this instance, /assets actually represents the static components of our page, so images, for example. So in order to diagnose this a little bit deeper and determine the root cause of this problem, I think I'm going to need to add another visualization to the page. So here I can just click Edit, Add, and I'm going to add a pre-prepared view visualization called Top URLs. Now, prior to this may have been noisy with the full data set. When I add the visualization, it actually just adds it to the bottom of the page, waiting for me to relocate it to an appropriate position. Immediately, I can see that the accesses here on the 404s are dominated by 5 or 6 SVGs: Twitter, Facebook, Zing, LinkedIn, and YouTube. So in this case, I've probably got enough information to take this to my operations team and say, I think maybe the static portions or the asset portions of our site, maybe we have a CDN issue, but more likely we've done a deployment and there's some static links that are lying around. Right, so whilst all of the previous is pretty simple and it's very effective when the issue is obvious, it does rely on our administrators spotting issues and using the drill down and search capabilities of Kibana to identify the root cause of an operational issue. Now, whilst we could deploy an alerting system now and say, tell me when the number of 404s exceeds a threshold, these typically result in alert fatigue. So as touched on briefly in the webinar, we're going to use ML to overcome the limitations of static rule-based alerting. So for the next demo, I'm going to explore XPAC's machine learning anomaly detection capabilities in a bit more detail in conjunction with the Elasticstack's more traditional search and visualization tooling to try and diagnose a potential issue. I'm going to continue with the website use case, but I'm going to introduce a greater breadth of data sources to diagnose issues deeper into the stack. To do this, we're going to need a little bit of a deeper understanding of our infrastructure. So I've prepared a dashboard here showing the overview of our infrastructure. As you can see, each of these boxes represents one of our sites powering our website, one of our geographical distributions. And as you can see, we've deployed the website across 4 global regions: North America, APAC, South America, and EMEA. And each of these deployments is independent of the other. Now, I'm only going to show the key components of the demo here. In reality, this is really a simplification of our infrastructure. I'm not, for example, showing databases or CMS systems or a variety of other components that are used to power this website. But if I scroll down in a little bit more detail, I can see one of these nodes, one of these sites in a larger view. And here you can see the Paleo site itself is powered by Apache. When users issue queries through the website, searches, these searches are forwarded to a search proxy, which populates an ES template and then uses the client library to round robin the requests across a 3-node Elasticsearch cluster. So each of the Elasticsearch clusters are completely independent in each of these sites. Now, I'm obviously focusing here on Elasticsearch because the issue that we're going to try and diagnose is Elasticsearch related. Now, in addition to that, we capture data from each of these regions. So we're capturing Filebeat traffic using, Apache weblog traffic that we've already seen using Filebeat. We're collecting the search proxy logs where we do our translation of our terms to an Elasticsearch query, again with Filebeat. And then on each of the nodes, we've obviously installed XPack monitoring, in addition to Filebeat collecting things like system auth logs and MetricBeat. And MetricBeat is actually installed, as is Filebeat, collecting system and auth logs on every machine in our infrastructure. But in this particular case, we're just focusing on those that are installed on our 3-node cluster. And then we have an operational analytics stack, which is independent of all the other clusters which we push our data to. Okay, so that just sets the scene, and we have a basic understanding of our infrastructure that's relevant to this demo. Now, let's suppose we receive an email, hopefully at a convenient time. And I've received this email, and it's dropped into my inbox, and I've received an alert, maybe in Slack, saying website activity, and we've got slow response times on our website. And email is identifying the /search portion of the website. So we have issues with our underlying Elasticsearch infrastructure, and it's experiencing slower than usual response times. So to be clear here, what's actually generating this is an XPack machine learning job has detected that an area of our website is experiencing performance issues. It's to try to attribute this to a specific area, in this instance, /search, and then it's generated a document which XPack Alerting has in turn detected and sent us an email with the relevant text. This link to try and explore this issue and try and identify the root cause. And this will immediately take us through to the Anomaly Explorer view of XPack Machine Learning. Now, there's a lot going on this screen, so I'm just going to go through what's here and try to explain each of the components before we actually delve into our specific issue. Now, we're currently only looking at the results for a single job which was relevant to the email, 1A site performance issue. Potentially, I could add multiple jobs to this view and cross-correlate those jobs, and we will do that later. But for now, let's just focus on this single job. The specific job here is using the Apache logs from our previous demo, with the ultimate aim to detect slow areas of the site, which are exhibiting performance issues that are slower than usual. Now, we consider each part of the site independently, and these are our sites listed here, and we're using the site area _1 field. And we do that because these areas of the site obviously experience or exhibit very different performance characteristics. For example, the blog portion of the site is very likely to exhibit different performance characteristics than search and download. To do this, we use a feature of XPack Machine Learning known as partitioning. And for those of you with some familiarity of our machine learning, the detector here is simply looking for high mean response time on each part of the page, partitioned by this site area 1 field. And it's that partition which causes a separate model to be built for each part of the site. Now, you can see a lot of colors. These represent the severity of the varying anomalies. The scale here is light blue warning, yellow minor, orange major, and red critical. And normally we would and these scales actually normalize partition anomaly score between 0 and 100. So anything greater than 75 plus represents critical. Whilst lower scoring anomalies are not usually typically worth alerting on, and we usually only alert on these critical anomalies, they are potentially interesting when combined across machine learning jobs if investigating other critical anomalies. So the first view I'm going to explain is this overall view. This is the simplest to interpret, and here we summarize all of the anomalies across the job. And it's this anomaly on the far right, which is the one that we're actually going to be interested in. Beneath that, we have the tile view. And here we show the anomalies by a specific influencer. Here, we've actually got our first influencer selected, which is the site area 1, which is the field that we built our model on. However, we have other influences here, for example, region. Now, this brings us on to, well, what is an influencer? So, on identifying an anomaly, machine learning tries to identify the cause. Prior to running this job, we specify fields to use whose values may be responsible for the anomaly, and we call these fields influencers. So on identifying an anomaly, we try to identify the values in the influencer fields for the associated documents which might be responsible for that particular anomaly. So here, for example, we've detected an anomaly and we've attributed the value to the EMEA region, with the EMEA value in the region field. So to think of this another way, if I removed all the documents for a particular field with value, for a particular field X with value Y, does the anomaly go away? If so, then we know X and Y, the field and the value, are responsible for the anomaly. And this is really a powerful way for us to get to the root cause of the issue faster and resolve the problem at hand. And we can navigate these influences here and pivot our results by particular influences. And we've also got the influences summarized on the left view here. So you can see that we've had anomalies that have been attributed to nearly all our regions, various areas of our sites, and I've also used the country name as an influencer, and finally site area too, which, as you may recall, was the first two parts of the URL. So let's select one of these anomalies, and I'm going to just for the purposes of example, select this anomaly here. And I would hope that most of these have been addressed earlier in the week, a lot of these critical anomalies. When I select an anomaly, I'm presented with a small graph view just showing me the pattern of the data and the anomaly itself. And it's pretty obvious here that the slash start area of the site has got a fairly large spike. So here, immediately we can see that it's been given an anomaly score, the time, and more importantly, we can see that the actual values attributed to Hong Kong in the country and the North American region. So I should have stated earlier, but I would expect users to be routed to the correct region based on their geographical location. So maybe we have a routing issue here and Hong Kong users are incorrectly being routed to the North America region. I also see the expected value. So I expected this page to return, or this area of the site to have an average performance of 69 milliseconds, and it's actually exhibiting 284, which is 4 times slower than usual. Okay, so now let's get on to investigating our specific issues. And the anomaly that I'd be interested in is this one here, which is the slash search. So I would expect this to show, yes, the slash search area of the site. And we can see that the performance has suddenly spiked in the last few minutes. Scrolling down, I can see we have a high severity issue. And this anomaly should correspond with this anomaly here, and more specifically, this slash search anomaly here. So scrolling down, I can see that immediately I have an issue in the United States, okay, in the North American region. Now, that's to be expected. United States users would, as you'd expect, be routed to that particular region. I can also see immediately that it's occurred at about 9 o'clock in the evening. Okay, so as somebody with a familiarity of Elasticsearch, my next question would be, to try and associate this with maybe this spike in query performance. Can I attribute it to maybe an increase in the number of queries we are receiving? Maybe North America is a frenzy of activity, and this is perfect, and this spike in performance is to be expected. So just quickly returning to our architectural diagram, you can see that these searches, as I mentioned, are routed through this search proxy layer. And I know that every search coming from the Apache logs or every search coming from the website equates to a single line entry in the search proxy logs. So in theory, I'm just looking for has the number of documents, if I'm converting each line to a document, suddenly increased in the last, say, 15 or 20 minutes. Now, I could use, in theory, a Kibana visualization here, but let's see what we can do with machine learning from an investigative perspective. So I'm going to click on the machine learning view, and I'm actually going to create a new job to try and see whether we have a spike in the number of queries. Here I'm going to select Create New Job, and I'm presented with a few options. Now, going into each of these in detail is a little beyond scope, and in the interest of time, I'm just going to provide a quick summary. So a single metric job allows us to look for anomalies in a single numeric field over the time, or potentially counts in the changes in the counts of documents. And a multi-metric allows us to look for multiple numeric fields, as well as using that partition functionality I touched on earlier. So build a separate model for every value in this field. The advanced job is a lot more complex and allows us to use a wider breadth of detectors and functions, as well as combine these detectors to conform more complex signatures. So from that description, it should be obvious we can either create a single metric job to solve this or a multi-metric. I'm actually going to select multi-metric as it introduces some important concepts, and it allows us to use that partition functionality to look for spikes in each region independently. Next, I'm presented with either an index to select or a save search. And I know that all of my proxy logs are in this particular index pattern here, search HTTP proxy, like HTTP logs. So I'm going to select that index. Okay. Now, knowing that each log line represents a search, we simply want to know if the count is high in any specific period. First of all, I'm going to use the full data set, and I'm going to say, is the count high? Okay, we can see nothing particularly interesting in this data at this time. But next, I want to split on a specific field. Now, I would expect maybe the number of queries going to each region to differ quite wildly. So, for example, North America probably receives more queries than APAC, hypothetically. It may not, but it may. So let's split on the region field in order to create a separate model for each region. And we have 4 regions, and we can immediately see that the pattern of our data is a lot clearer. And this is just cyclic patterns that maybe we expect during the hours of the day. Key fields here, now these represent the influencers. So what fields might we attribute to anomalies? The region, as we petitioned on it, is automatically selected for us as an influencer, and I'm also going to select server name. This actually represents the Elasticsearch instance that the query is being routed to by the search proxy layer. So maybe we can use this to attribute any anomalies to a specific Elasticsearch instance. Maybe we have an issue in our routing logic, and an instance is receiving more queries than it should. Okay, next, we need to select a bucket span. Now, this specifies how we divide up our continuous stream of data into batches for processing. Here, we're going to use a bucket span of 5 minutes, which means that every 5 minutes, we look at the previous 5 minutes and calculate the number of documents in each bucket and determine whether this is high based on the previous behavior. And that will be done for each model and each region independently. I've selected 5.5. Choosing a bucket span, I've selected 5 minutes. Choosing a bucket span has a few considerations: performance, timeliness, and quality of results. And we've recently published an excellent blog post which goes into this topic in a little bit more detail. For us, 5 minutes gives us a reasonable responsiveness in the job, and it means that we'll be alerted within 5 minutes of a high number of requests, whilst also the job will remain performant, and it should summarize our data quite nicely. From version 5.5, we actually get this estimate bucket span, which applies a number of heuristics, which are discussed in the blog post, and it actually is determined that 5 minutes is also a good value. So that's great. Now we need to give our job a name, and I'm going to call it High Query Volume. And I'm going to call it this demo, and I'm going to click Create. Now, by clicking Create, this actually causes the job to run. During this time, XPack Machine Learning uses a series of aggregations to collect counts in each bucket span, moving a sliding window across the data and historical data and training our statistical model for high count over time. It also, as you can see, begins to highlight the results to provide a rough indication if any anomalies are found. And it's already done. So that's processing, I think, about a couple of million documents, and it's done that in a few seconds. Right, now we're pretty much ready to look at the results. So let's take a look at the results. And this should take us through to the Anomaly Explorer view. Now, as you can see, we've got a number of spikes and anomalies, nothing critical in search throughput, and they seem to roughly coincide with respect to the regions. Probably these are just spikes in daily activity, and these particular anomalies are just on maybe a sales day or a campaign that we're running, and more people are searching. Disappointingly, though, I don't actually have any anomalies in the period I'm interested in, which is over on the right-hand side here. To confirm that, I'm going to try and correlate this with my earlier job. So I'm going to add the previous job that I had before looking for site performance issues on performance, main view, adding it in, and yes, this pretty much immediately confirms that we still have a critical anomaly as a result of the site performance issue job, but we don't have anything associated with the rise in query performance, query throughput, sorry. So let's recap. We've identified an issue on our website currently associated with search performance, and we can't attribute that to a spike in the number of queries. Now, if we can't attribute this lowering performance to a rise in search throughput, we need to dig a little bit deeper. If search throughput is not a problem, maybe we can attribute our search woes to a particularly Elasticsearch instance. As Elasticsearch administrators, our next step might be to look for the server responsible for our search slowdown by looking at maybe resource utilization. Now, as mentioned earlier, we've installed Metricbeak on every server in our infrastructure. This is capturing useful metrics regarding CPU, disk, and memory. And we can use these metrics in machine learning. Machine learning can use these metrics for highlighting resource consumption hotspots in our infrastructure. These types of jobs are not that useful typically on their own, and I normally wouldn't alert on them. They do tend to be sparse and generate a lot of noise, but they can be useful from an investigative perspective when combining with other jobs. And I prepared a job here, and it's actually looking for an increase in CPU I/O wait time. And normally I would have a number of these, but for the interest of time, we're going to focus on CPU I/O wait time. We could be looking at other things like high memory consumption. And I'm going to add this job to the swim lane. Great, and you can see immediately that we do have an anomaly in our I/O wait time on one of the servers in our infrastructure, and it correlates with this site performance issue. So selecting this anomaly and looking at the results, I can see that the time the CPUs have waited in I/O wait has spiked. And in this particular job, I've actually used the host name or the beat.name, which is the equivalent of host name, as the influencer. And it's attributing this issue to site search ES1. Now, if I was to return to my architecture diagram, that actually is consistent with the North American region. So now we know we have a search performance issue in this particular region. It's not due to search throughput, but it's attributed to, we have some resource utilization spikes on this particular server and node. So at this point, I'd like to go and delve a little bit deeper. Now, fortunately, when we create a machine learning job, we can associate links with the job. So we can provide a unique URL with the job configuration and say, if a job spots an anomaly, attribute this unique URL to the anomaly, attach it and provide it as a hyperlink, and substitute values into the URL associated with the influencers. This allows us to explore and delve off into maybe other parts of Kibana. For example, I could now go and look at the log data for this particular ES instance or this particular node, or maybe it could take us to a dashboard. However, I know that Site Search ES1 is an Elasticsearch node. So where I really want to go now is XPack monitoring. Going across, I can see the link exposed here, monitor node. And I'm going to go to XPack monitoring to try and explore this anomaly in a little bit deeper. For those of you not familiar with XPack monitoring, our first view here is the overall view, which shows the behavior of our cluster at a high level. XPack monitoring uses an agent on each of the ES instances to index documents containing the stats and the behavior of the node, and then we present the ones that we consider to be the most important in diagnosing issues. So immediately, this is looking at the cluster on the North American region, where we think we have high resource consumption in one of our nodes. And we're maybe hypothetically at the moment just trying to connect this to search performance. But my attention's immediately drawn to this spike in query performance. But more interestingly, also that suddenly we've got a large amount of indexing occurring. Now, this is just a classic website. We do update pages. We do have people commenting on the website, and we are constantly publishing new and updating content. But we definitely don't expect 4,000 documents a second. So maybe somebody within our organization has kicked off an indexing job, maybe with this into an index with a single shard, and it's placing this node under quite a lot of load. Now, let's try and confirm this. So I'm going to go to the nodes view, where I should see, and I do immediately, that the CPU is high on Site Search ES1, as you would expect. It's been detected by our ML job. What really draws my attention here is this JVM statistic. So why is this node at 76% and these two are at 20%? Let's take a look at this node, which we think is the cause of our problems, in a little bit more detail. I'm going to go to the advanced view, which just introduces a few more charts. And I can immediately see that, okay, so my search performance has jumped, but I've got suddenly a large amount of time spent in garbage collection here, and my CPU utilization is high, as I would expect. It's flatlining at almost 100%. So the garbage collection seemed to be responsible, and probably responsible for this CPU utilization. But what's more interesting is this change in the heap here. So previously I was using a 4 GB heap, and now I'm only using a 1 GB heap. So something seems to have occurred in this time span whereby my heap's been resized, and that was about 18 hours previously. And then later, this had a fairly healthy sawtooth profile, but then maybe this indexing has caused a large amount of garbage collections on this small heap, on this new 1 GB heap, and that's what's caused the degradation. And if I looked at the other nodes, I would probably be curious to see whether they too have. No, they've actually got a 4 GB heap. So it looks like we've just had a reconfiguration on one node. Okay, so at this point, I've gone about as far as I can with XPack monitoring, and I really need to look at the other data that we collect on all of our machines and our infrastructure. More specifically, I'd like to look at Site Search ES1 in a little bit more detail. And to do this, I'm going to use a Kibana dashboard. So, returning to our dashboards, I've prepared a server overview dashboard. Now, this is actually visualizing all of the data collected from MetricBeat on all of our infrastructure. And it's really designed to look at a single server at once. So, and that's important, but it also collects, it was also showing the syslog data and all the messages that are being collected on the servers. And we can also see the SSH accesses from the FileBeat auth module and where those accesses are coming from. Additionally, we have some charts on file system space and network traffic. Now, at the top, we show the memory usage over time, and also we show the CPU usage. And these little blue tags are just logons to individual servers, where we get some extra details. So who logged on and onto what server. Now, this dashboard as an overview across many servers isn't particularly useful. So it's really designed for looking at a single server in detail. So here I'm going to look for my particular server. And to do this, I'm going to use an Elasticsearch filter. I'm going to add a beat name. And we are looking for Site Search ES1. Let's apply that as a filter to the page. Great. So the visualizations are now restricted to a single server, Site Search ES1. We can see the CPU utilization, the memory usage, and the file system usage. And there's these gaps in the data. Now, these are probably MetricBeat restarting. So this visualization is obviously built from MetricBeat and some of these others from FileBeat. But this looks like MetricBeat restarting associated with logins. And that's probably something I want to investigate later. What I'm really interested in is this drop in memory utilization here, And obviously our CPU spike here is the issue. But this is where the real root cause of the problem occurred. So let's restrict to that particular time period. And when I look, I can see that only one IP address is logged in this period, and it's the Ansible user. Okay, good. So an Ansible user is logged in from that IP address on Site Search ES1. That's probably enough to take to my manager and my operations team and say, look, I think somebody resized this ES heap, this Elasticsearch heap, but let's search for just Elasticsearch and see if we have any syslog messages. And scrolling down, yeah, so we can see that Elasticsearch, somebody logged in and stopped Elasticsearch at 0120 on the 22nd, and then it was restarted again at 3 minutes past 1. Okay, so in summary, we've alerted on a performance issue with the search component of our site. Using machine learning, XPack monitoring, and finally a simple Kibana dashboard, we were able to diagnose the issue and the underlying root cause in a few minutes. But in future, I'd really like to prevent this issue occurring again, or at least identify the root cause much earlier. So I'm going to go through, now ideally we would set the job up here, but in the interest of time, I prepared a few jobs that are prepared earlier to provide us with earlier notification of this issue. The two characteristics that I probably would have looked for would have been high indexing time and also GC time. So let's look at indexing time first of all. And this is an advanced job, and it's using a derivative aggregation to look for changes in the amount of indexing going into our nodes. And it did actually spot the issue an hour before it occurred, which is encouraging. But really, what I really would like to have alerted on was that GC. So if I had a job which had looked for a derivative on the amount of time spent in garbage collections, and if I add this job to the same view, then this would have actually detected the issue about 18 hours previously. So this is really the job that we should have had set up. And as a post-analysis, I'd have set this job up and set up an XPack alert on it. Okay, so that's it for the demo. I'm going to hand back for Jamie to close out, and we'll then go to questions.
Thanks, Dale. That was great. Had a nice recap also. So in closing, we want to make sure you're aware of Elasticon, get some updates, a couple different places you can go, find out when the next one's happening. You can go to elastic.co, Elasticon updates, and there's also an Elasticon tour, which you can see here, and these links will also be active in the notes when we send them out. And thank you very much for your time. Do we have any questions that we want to try to go over? Or I saw some things and I tried to answer some in the IRC as we were going, but I'm not sure if there is anything outstanding.
So Jamie, we've got a few. The first was, are the gauge and goal visualizations custom Kibana visualizations? They aren't actually. They were introduced in 5.4, 5.5, so they are quite recent for those people that are not familiar with them. But you can check those out, and there's a recent webinar on new visualizations in Kibana 5.x, so I'd recommend that you check that out. We were asked if it's possible to honor the parent-child relationship between documents in Kibana. Currently, it's not, actually. We don't use parent-child in Kibana. In this particular use case, operational analytics, this form of modeling is actually quite rare. It's typically more common for people using Elasticsearch for things like business analytics, but for operational analytics, predominantly for performance reasons, it's actually not a type of modeling that we would use anyway. But it's unfortunately, no, it's not supported in Kibana, so you will need to denormalize. We used CollectD for OS application metrics. Is it possible to send these directly to Elasticsearch and bypass Logstash? This makes managing the environment and resiliency limitations with this makes the environment to manage and resiliency limitations with Logstash are negated. Okay, so I would add a couple of things there. As far as I'm not familiar with CollectD. I would just address the resiliency limitations of Logstash. We have introduced persistent queues in Logstash now. So we do actually guarantee end-to-end delivery on Logstash with the right settings in Logstash persistent queues. I think that was introduced in 5.4 in beta, and it's now GA in 5.5. So I can't answer the specific question with Collect D. Maybe you can, Jamie, but I would still probably suggest that that would need to go through Logstash. And then there's another question: how do we generate those vertical lines of a login event? So that top chart is actually achieved, and I could share my screen if it's helpful. That top visualization, I have to go to it, is actually uses something called time series visualizer, which is also new in 5.4, 5.5. And this time series visualizer allows you to actually attach what we call annotations to the time series. And in this instance, you can, these annotations, if I go to here, I can actually specify an index, and I can specify a query, and then I can use specific documents for these annotations. So in this instance, I'm saying restrict the FileBeat data to the auth data, so everything being collected by the FileBeat auth module, and only accepted events, so successful login events, and then I'm just telling it to use these fields and a pattern to formulate these particular labels. Okay, hopefully that answers the question. Anything else? So what is the maximum performance for receiving events in Logstash, UDP, TCP? So I would imagine, just because UDP has a performance, is the nature of UDP, that it doesn't guarantee delivery, that it would probably exhibit faster performance as an input. Typically, I don't think that would be the bottleneck in delivering messages. 100,000 messages a second isn't particularly high. I would use TCP because UDP really makes no guarantees on delivery. So UDP as an input to be faster, but that's unlikely to be the bottleneck in any chain.
There's also many variables that would be coming into play: network speed and the CPU speed of the Logstash servers. Yeah,
I'd agree with that. Okay. I think we're going to end the webinar, but we'll stay on IRC for a few minutes, just answering any additional questions. Jamie, anything to wrap up?
No, that's all. Thank you all very much.